All right, welcome back. Now, previously we have learned what bag of words is, and we got to understand that we need to make sure that our text is actually converted to a vector form, that is in numeric form, so that we'll be able to feed it to any natural language processing algorithm to build a model. All right, so we got to understand that we can do that by converting the tokens into vectors. Okay, so we learned about where we can represent the tokens with the idea of bag of words. All right, and also with just vectors. Okay, we've learned that. Now, the process of converting these text into vectors is referred to as vectorization. Okay, text vectorization, right, which is the process of converting the text into numerical representation. Okay, that we can feed to NLP algorithms to build models. So the techniques to do this are bag of words, TF-IDF, and then we also have word-to-vec, okay, which we will see later on in this course. All right, we will dive deep into this, right? There's a whole lesson on that, right? But for now, we've seen bag of words, okay? We've seen bag of words. So we say that bag of words is a representation of text that describes the occurrence of words within a document. Okay, so we have a document and then we see how often a particular word occurs. Okay, we saw how we do that. Well, on the Excel sheet we saw that. All right, so our main concern or the idea here is to check the occurrence of the word within the document. Okay, so over here we just keep track of the word count. Okay, we just keep track of the word count, and then we disregard the grammatical details. Okay, whether prepositions come before verb or verb comes before preposition, all those concord and grammatical things we don't care. What we care about is how often a word appears. Okay, that's what we do. Okay, the model will only concern itself with whether a word occurs or in the document or not, right? Not where the word actually occurs. Okay, so that is bag of words. That's how we do bag of words. Now we're going to consider another one, which is TF-IDF. Okay, so in bag of words, we got to understand that there are certain words that will come quite frequently. Okay, so certain words might appear over and over again, which will have so many counts. Okay, so many counts in there. Okay, so many counts in there, which will overshadow the others. But maybe those kind of words that are appearing quite often are not important, right? Are not important. So for instance, something like maybe a word like maybe there, right, may come quite often, but there will not be contributing much to the overall meaning of the word or the overall meaning of the vocabulary that we are using. Okay, so we want to deal with that. And that's when TF-IDF comes into play. Okay, so what TF-IDF is doing is also converting the words into vectors. Okay, with some form of semantic meaning. Okay, some form of semantic meaning. What I mean by that is that it's going to give a weight, right, or importance to the uncommon words. Okay, so words that do not frequently appear, it's going to give weight to them. But those words that frequently appear, like there is some other words, okay, that frequently appears, right, it's just going to penalize them by giving less importance to it. Okay, by giving less importance to it. So that's what TF-IDF is going to do, right? And most of the time, you're going to need TF-IDF in preparing your data, okay, because it works quite well for us. It's quite robust. All right, it helps you to focus more on the words that gives meaning and that contribute much to building your model. Okay, we will later on see word-to-vec. Okay, which is a whole lesson on its own. All right, so now let's take this TF-IDF and then try to understand it through an example. Okay, that will make it more clear. All right, so let's consider a situation over here. So here we are assuming that there's a word. Okay, there's a word document. Okay, and that word document contains 1,000 words, right? And out of that 1,000 words, we have dog appearing 4 times. Okay, so we have a word document, right, which contains 1,000 words, and among the 1,000 words, a dog appears 4 times. Okay, dog appears 4 times. Now, if we calculate the TF of that is the term frequency, how frequent the that term, which is dog, appears in the 1,000 words, we're going to divide how many times that word appears by the total number of words. So we have 4 divided by 1,000. okay, because doc appears 4 times in the overall 1,000 words. So we divide it, okay, and then totally we will have 0.004. Okay, now let's consider another scenario where the same word, right, the same word, which is doc, appear 50 times in 1 million documents. So here we have a single document, but here the overall documents are 1 million. That is the entire corpus, okay, the entire data set. When we pick just one document out of this 1 million, doc appears 4 times, but in all the documents, doc appears 50 times. Okay, so that's when you calculate the inverse document frequency, IDF. Okay, so here we calculate the term frequency. That is how frequent that term appears on a single document. Okay, and then here we calculate the inverse document frequency, how often that word appears in the entire document. Okay, now we are saying that the doc, that is the word or the term doc, appears 50 times in the entire document. So to calculate the IDF, we use log, right? Log of the entire document, which is 1 million, divided by 50. Okay, remember it is inverse document frequency. So the entire document divided by the number of times the term appears. Okay, so when we divide this thing and then we find the log of that, we're going to have 4.3. Okay, so now if we calculate the entire TF-IDF, okay, remember here we have calculated the TF, here we have calculated the IDF. So if we calculate the entire TF-IDF, then we're going to multiply this one, 0.004, which is the TF, by the IDF, which is the 4.3, and then the total we have 0.0172. Okay, so now we have been able to calculate the TF-IDF of this scenario. Okay, now let's consider another scenario here. Okay, let us assume that the word is, so here we are considering the word dog, right, or the term dog. All right, now here the term dog was appearing 4 times. Now in this case we are saying that the term is appearing 50 times. Okay, it appears 50 times in a single document which contains 1,000 words. Okay, it appears 50 times which contains 1,000 words. So if we want to calculate the TF just like we did over here, then it's going to be 50 divided by 1,000. Okay, and then when we work out, we're going to have 0.05. All right, now let's say that the same word, which is the same is, appears in all the 1 million documents. Here the dog appears 50 times in all the documents, but here it appears in all the documents, right? In all the 1 million documents, is appeared over there. So in that case, if we want to calculate the inverse document frequency, which is the IDF, then we're going to have a log of the 1 million divided by 1 million, because we are saying that the dog appears in all the 1 million documents. So it's just 1 million over 1 million. And in that case, we're going to have 1 million divided by 1 million is going to be 1. And if we find the log of 1, we're going to have 0. Okay, now if we calculate the TF-IDF, okay, if we calculate the TF-IDF, it's going to be 0.05 multiplied by the 0, which in this case is going to be 0. Okay, now you see, if you realize the term frequency, right, although the is appeared most frequently, 0.05, okay, 50 times, okay, here just 4 times, and you can see that the TF was very, very less, 0.004, but here the TF was high, 0.05, okay, although is appeared many times, but since we are using TF-IDF and we calculate the inverse of it, that is inverse document frequency, we ended up getting 0, and when we multiply, we penalize it because it appears mostly. We realize that okay, is not really significant in this document, because even in all the other documents it's appearing over there, right? It's appearing multiple times over there, so we can't give more importance to it over here, although it appears much, but it's just the same thing, right? It's nothing special, right? But dog appears 4 times on this document, okay? And when we look through all the other documents, it appears only 50 times. It means that it's having significant, okay? So that's why it's having a value over there, okay? So that's basically what we do in TF-IDF, right? All the words in the document are going to be calculated with their respective TF-IDF, and that's going to form the vector for us. Okay, that's what is going to form the vector for us. When we go to the lab session and we are doing projects, we are not actually going to calculate it as we are doing here, right? Because we have what is called TF-IDF vectorizer, right? TF-IDF vectorizer, which we use in converting all the raw documents to matrix, right, of TF-IDF features, right? So you're going to, for instance, S is going to be represented with 0, dog is going to be represented with this value 0.0172, right? In the same way with all the other terms or all the other words or tokens, okay, they are going to have their respective TF-IDF. Okay, so this one is quite robust because it helps us to ignore those words that are not important. Okay, of course you can do you can remove stop words. Okay, you can remove stop words, but there are still going to be some words that are not going to have that much importance, which are not present in stop words, which TF-IDF vectorizer will take care of that for us. Okay, so you're going to see much of these things when we get to the lab session, but this is the idea. Okay, this is the idea behind it. Okay, we have the bag of words, then we also have the TF-IDF, right? We're also going to see as I said, where to vec later on. All right, so now once you're able to use either TF-IDF vectorizer or the bag of words to convert your text into vector form, then you can now use traditional machine learning methods in building your NLP models. Okay, in building your NLP models. So for instance, with this kind of test that we have here, we can use the TF-IDF to convert all of them to vector form. Okay, we can also use the bag of words if we want, right, or the TF-IDF, either of them. Okay, and then after that we can feed that to a natural language processing algorithm. Okay, so after we have converted all of them, right, it's going to be a very long, because all these things are going to be converted using the TF-IDF or the bag of words, and we're going to have a very long vector over there, right, up to the size of the vocabulary that we have. Okay, then now once we have all of them like that, we can feed it to an algo, right? We can feed it to an algorithm to build a model. Okay, something like that. Okay, so basically that's what we do, right? So we're going to see more of these things practically as we move on to the lab session. All right, as we start doing some project, we're going to see how we convert all our text to a vector form, and then from vector form we choose NLP algorithm, and then we build a model to perform some sort of a task over there, or solve some sort of a use case. Okay.